Good morning, Algebra 2 students. Today we're going to talk about graphing logarithmic functions, and this was that first problem on the back of the practice summative. It's important to realize that a logarithmic function is an inverse of an exponential function. An inverse of an exponential function. So how you've graphed the exponential functions, the x's and y's will be switched, and you'll see that pattern here shortly. So getting started with this first one, log base 3 of x, we're looking for powers of 3 that we could do mentally. So for example, the log of 1 we know is always 0. Log base 3 of 3 is a power of 3. So the log base 3 of 3 would be 1. The log base 3 of 9 would be 2, and the log base 3 of 1/3 would be -1. If you remember, those points are just switched around from the graph of y equals 3 to the x, which is what we started with 0, 1, 1, 3, 2, 9, and so on. Okay, so we would plot those points. We've got 1, 0, we've got 3, 1, we have 9, 2, we have -1, 1/3, or 1/3, -1. And you can see this graph looks like this. It's going to get closer and closer to 0 on the x-axis this time. And the domain would be x is greater than 0. And the range would be all reals. So once again, that's switched around from when we graphed exponential functions. All right, now if there are changes to this graph, so let's say I've got x plus 2 in parentheses. That's like on the inside, so this is going to move this graph left 2. If I had a number out here, adding and subtracting, let's say -1, that would move this graph down 1. So again, we start with those basic points, just like we did with the exponential. Now we would move each of these points left 2. So I'm going to start with the 1, 0 point. If I move left 2, down 1, that would be right there. The 3, 1 point, if I go left 2, down 1, I'm right at 1, 0. The 9, 2 point, I would go left 3 and down 1, and I would be at 6, 1. Okay, this graph is going to get closer and closer to -2 now, and it would look like this. The domain of this one then would be x has to be greater than -2, and the range would be all reals because it is extending infinitely up and infinitely down. Here's another example. We're graphing the log base 2 of x. Those points that we're going to start with would be 1, 0, 2, 1, 4, 2, 1/2, -1. Again, those are switched around from the exponential. So those are going to be my starting points. Let's start with those. We got 1, 0, we have 2, 1. We have 4, 2, we have 1/2, -1. You see that general shape of that graph starting right now. Then again, if I've got, let's say, x plus 3 in parentheses, that's going to move the graph 3 left. Let's say I've got a plus 4 out here, that would move this graph up 4. So now each of these particular points, I'm going to go 3 left, and then up 4, left 3 and up 4. So moving these points, each of those left 3 and up 4. This graph is going to get closer and closer to -3. So the graph will have this shape. The domain is going to be x is greater than -3, And again, the range would be all reals. Another example here, we're starting with log base 4 of x, so those points are going to be 1, 0, as we always have, 4, 1. We'd have 16, 2. Again, we're going to be way off the graph there. We'd have 1/4, -1. We will plot those points. We've got 1, 0, 4, 1, 1/4, -1. Okay, and then again, some changes. If I do, let's say I've got x minus 2 here in the inside, that's going to go 2 to the right. All right, if I put a number in front, let's say I put a 3 here, that's going to triple the y's again. So the same thing we've been doing before. So each of these points I would move right 2. So this 1, 0 point going right 2, I'm at 3, 0. Obviously taking 0 times 3 doesn't do anything, so I'm at 3, 0. The 4, 1 point, moving it right 2, I'd be at 6, 1. And then multiplying the 1 by 3, I would be at 6, 3. The 1/4, -1, moving it to the right 2, I'd be at 2 1/4, -1, which is 2 1/4, -3 then. This graph's going to look like this. Your domain is going to be x is greater than +2, and the range again would be all reals. All right, you could also do this with the points. So moving right 2 would move each of these the x coordinates. This would become 2 1/4. This would be 3, 6, 18. Tripling the y's, I'd have -3, 0, 3, and 6. And you can see those are the points that I just graphed. So I hope this helps you with problem number 5 on that summative assessment. Tomorrow, Wednesday, I'll be gone. We'll have a sub, which you'll be reviewing for this summative assessment, and then preparing to take that summative on Friday. This problem will be part of that, so take some time to review with this and to discuss this with some of your classmates.